All right, so number 1 says there are a total of 184 teachers at CHS 9, and there are 3 times as many female teachers as male teachers. And then the question is, how many female teachers are there? Okay, so I always start with what the question is. How many female teachers are there? Because that tells you how you want to define your variables. So we're going to let x equal the number of female teachers. That's the unknown. That's what we want to know. So that's our variable. We also don't know how many male teachers there are, so that's going to be our second variable. Oops. You're always going to get 2 variables and 2 equations for these. So number of female teachers and number of male teachers. Okay, and so I don't know what those numbers are individually, but I know if I were to add them together, there's a total of 184 teachers. Okay, and so the other equation isn't going to have the 184. Once you use the 184, you don't get to use it in the second equation. The other equation comes from the fact that there are 3 times as many female teachers. So female teachers equals 3 times the male teachers. Okay, whatever comes first in the sentence, it's automatically going to be that variable equals. That trick always works. That's the bigger number. So we get the number of female teachers by multiplying the smaller number, the male teachers, by 3. Okay, and so this bottom equation.
Wait, sorry. X equals 3.
Yeah.
Wait, how did we get that?
So the number of female teachers is X, and it's 3 times the number of male teachers. And so X equals 3 times Y. Okay, and so this bottom equation is Desmos ready. As long as you have a variable solved for, you can type it into Desmos. And then the top equation, we can get it Desmos ready by either solving for the x or the y. To solve for the y, we're going to subtract x from both sides. And so now that one is Desmos ready.
Y equals.
Okay, and so I'm going to type in the orange one first. X equals 3y. And then y equals 184 minus x. And then that 184 is kind of big, so you're going to have to hunt for that. Zoom out a little bit. And then click on the intersection. The x ends up being 138. So I go up to where I've defined what x is, and that's where I write my answer. So x is 138. The y value is 46. And so if the question asks for the number of female teachers, we want to make sure we type in the 138. So our final answer would be 138 female teachers. Okay, next question says, the number of calories in a piece of pie is 20 less than 3 times the number of calories in a scoop of ice cream. The pie and ice cream together, so let's highlight that. The number of calories in a piece of pie is 20 less than 3 times the number in a scoop of ice cream. The pie and ice cream together have 500 calories. And then the question asks, how many calories are in each? So that's how we're going to define our variables. We'll let x be the number of calories in pi, and then we'll let y be the number of calories in ice cream. And you could use F and M and I and P as variables. The only reason I'm using X and Y is because test mode of Desmos only takes X and Y. And so if you have to solve it, I would use X and Y. Okay, so I don't know the number of calories in each individual item, but I know if I add them together, there's a total of 500 calories together. And so X plus Y equals 500. And so my next equation can't have the 500. You only get to use the 500 once. And so my next equations are just sentences. And so this sentence says there's a total of 500 calories. X plus Y, the total is 500. So the other sentence, the number of calories in a piece of pie is 20 less than the number in ice cream. So pi, which is X, is 20 less. So I'm going to skip a space and put minus 20. It's 20 less than something. And then that something is 3 times the scoop of ice cream. So 3 times the calories in ice cream. So my equation becomes x equals 3y minus 20. And so this bottom equation is Desmos ready. Because the x is already isolated. And then just like the last one, we can get the top equation Desmos ready by either solving for the x or the y. I'm going to solve for y just because I always have a habit of solving for y. And so y equals 500 minus x would be the Desmos ready.
Minus x.
Uh-huh. I'm going to type in the x equals 3y minus 20. That one's ready. And then now I'm going to type in y equals 500 minus x. Hunt for the intersection. There it is. 370, comma 130. So next to the x, I'm going to put the 370. Next to the y, I'm going to put the 130. And so those are our answers. And so you would just want to make sure you type them in the right blank. So 370 calories for pie, and then ice cream would be 130. And so some advice for these application problems on a test, they're going to be nice numbers. They're going to be whole numbers, especially if you're talking about teachers or items. And so it's not going to be any kind of ugly decimal to type in. All right, this next one is a review from Inequalities, and it comes from STAR, and it's going to show up on the test. And so it says the graph of this equation, there's an equal sign, is on this graph. So there's your line. That equation means it's a line. And then the question says which ordered pair is in the solution set of this inequality. And so a common mistake is people see that greater than sign and think they need to go ahead and shade above. but you are not ready to shade your graph. You can't shade your graph until you solve for y. Okay, and so along the way, we're going to have to divide by a -2, which would flip the inequality. And so that's why we can't shade until we solve for y. Okay, and so we have to be neat about this because we can't type it into Desmos. So I'm going to subtract the 3x from both sides. And then put the x term first because that's how slope-intercept form looks. Just make sure you don't combine the x term with your constant. Those aren't like terms. So write them both down with the x term first. And then we would divide each number individually by the -2 so that we can see what the slope and y-intercept is. And then this is the moment. We just divided by a negative, and so that causes this inequality to flip.
Wait, so why is it called the flip?
Anytime you divide an inequality by a negative, it flips the way the inequality is facing. And so that principle is a mathematical principle that will never go away. Anytime you divide an inequality by a negative, it flips. Don't flip it just because you see a negative. Just flip it if you divide by a negative. And so that's going to leave me with y. And then you can simplify these fractions in Desmos if you want to. -3 divided by -2 would give you a positive 3/2. And then positive 10 over -2 would give you a -5. The reason why we want to take our time and simplify this is because that 3/2 is your slope and -5 is your y-intercept, which is exactly what we have on our graph. They graphed the y-intercept at -5, and then they went up 3/2 to get the other points. And so that's not really what we're concerned about here. We're concerned about the inequality. And so the inequality is now a less than sign, which means we want to shade below. I always write the word below with the less than sign as the L to remind me I'm shading below the line. Okay. The other thing I want to note is that there's no line underneath this inequality, so our line is going to be dotted. And so anytime you have a dotted line, points on the line are not solutions. And that's always tricky because when you look at this graph, they graphed a solid line. And so you can, I'm going to get the white pen and make it dotted so that I don't get distracted and think that points on this line would be a solution. So it should be a dotted line, and then our shading is going to be below. Okay, and so to remind me which direction is below the line, I like to draw arrows pointing down from each point. Okay, so pointing down, pointing down, pointing down, whereas greater than would all be pointing up to this other region. And so that tells us which region to shade. That's why I shaded down here. And so now we can type or plot all these points and see which one's in the solution. If I plot 6, 4, 6, 4 lands right on the line. And so cross that off, that is not a solution. And then the point 5, 0, he's in the shaded region, so he works. The point 0, 5 is up here outside the shaded region, They're trying to get all the people who shaded the wrong region. And then the point 0, -5 is on the line again. So that one doesn't work. And so our answer is 5, 0. So on the line. And then same with the purple. It's on a dotted line. Can't be on a dotted line. Okay, and so this next page, we're putting them together. And so this time we have more than one inequality to graph. And so it's a system of inequalities. And so take it one at a time, starting with the top one. The y-intercept is -3. And so we're going to start at the -3 on the y-axis. And then the slope is 4. And so whenever the slope is a whole number, there's an invisible 1 on bottom, which means we're going to rise up 4 and run to the right 1. Rise over run. So up 4, right 1. Up 4, right 1 would give us some points. Okay, and then looking at the inequality, it's going to be above, since that doesn't make the L shape, and it's going to be dotted because there's no line underneath it. And so it's going to make the dotted line.
Wait, it's dotted because what?
There's not a line underneath this inequality. Okay, and so to shade above, I always draw my arrows pointing up. The steeper the line, the harder it is to tell what above the line would look like. And so that's why the arrows help me. And so above the line would be this region here.
Okay, the one that's you can do that one. Wait, how do you do the lead? What you get for number 10? Right? To get that, you need
Okay, and so for the other line,
Wait, sorry, why is it above?
because it's greater than, if it makes a less than sign, it would be a below. But since that doesn't make an L shape, it's greater than, so it's above. Okay, and so for the second line, the y-intercept is 3. And so we're going to start at 3. And then the slope is -2 over the invisible 1. So this time we're going to go down 2 for our rise, but still run to the right 1 to get our negative slope. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. We can also go up 2, back 1. And this time, they put a line underneath the inequality, so we're going to make it a solid line. And it's a greater than, so we're going to go above.
But what if you can go the other way, can't you? Why not?
Wait, aren't these all, these two are the same, like...
Right, yeah, there's an intersection. Okay, and so to shade above this line, my arrows would be pointing up. And so I would be shading all of this region over here. And so I don't like to take my time too much shading these regions because the only solution is where the shaded regions overlap. Okay, so this region in the middle, this triangle, got shaded twice. That's our solution set. So sometimes I get my eraser and erase all the other shading and just shade that part. Okay.
Just shade
That upper triangle. That's our solution set. Okay, and so this intersection point is actually not a solution. And the reason why it's not a solution is because one of your lines is dotted. The red line was dotted. And so anytime you land on a dotted line, even though it's also on a solid line, it's not going to work as a solution. And so another non-solution would be that.
Wait, so how do you know if it's dotted or not?
Because there was no line underneath this first inequality. And so this point right here would be a solution because it's on a solid boundary. So treat the solution set like a pool. You either want to be in the pool or on a solid foundation. You don't want to be standing on a solid line. Say not solution. Because this does have a solution. So for example, this point would be a solution. Any point in that shaded region or on this solid line would be a solution. Okay, so looking at the second one, the y-intercept is 3, so we're going to start there. And then the slope is -5. And so we're going to go down 5, right 1, down 5, right 1, and that's all we can fit on here. And this time they did take the time to draw the line, so we're going to take the time to do a solid line. So solid. And once again, it's a backwards L, and so it's going to be above. And so I'm going to go ahead and make...
I thought that if there was a line, that it was dotted.
No, if there's no line, like this first one was no line, so it was dotted. They take the time to draw the line. You're going to take the time to do a solid line. Okay, and so... let's make our solid line.
It's just 135 times.
And then to shade above, we would draw our arrows from our points pointing up, which would land us in this right region. And then I'm just going to roughly shade because I'm just going to delete it later after I get the other inequality on here. Okay, and so for y is greater than -2, that -2 doesn't have an x. And so that is your y-intercept. And whenever you don't have an x term, that means your slope is 0. So it's going to be a horizontal line through the -2, but it's going to be dotted because they don't have an inequality, equal sign under it. They don't have a line. So if they don't take the time to draw the line, it's going to be dotted and above.
Above because it's this way, right?
Right. So dotted and above. So we're going to get our dotted tool and make a dotted line through that point. And then above a horizontal line is really clear. It's above this line, all along the line. And so we would end up shading all of this region up here. And so the overlap, whenever you have two lines on the graph, you're going to end up with 4 different quadrants. You have this quadrant, this quadrant, this quadrant, or this quadrant. And so your goal is to decide which quadrant is your solution set. And so this is our solution set. And so I like to get rid of all of it except for the overlap, which would be just this part. Right here. And so if the question asks, is 1 - 2 a solution, we would say no. It's on a dotted line. So not a solution.
So for this one, all we have to do is graph it, right?
Right. And so I'm just labeling it because most of the time the questions will say, like, is 2, 0 a solution? And it would be because it's in the shaded region. Whereas, like, 3 - 2, not a solution. Whereas 0, 3 would be a solution. And then anything in the pool would be a solution. Just nothing on a dotted line. Okay, and so the last part is if they give you the graph, you need to be able to write the inequalities. So when I have to do that, take it one at a time. So I'm going to start with this one that has a y-intercept of 2. And so I know there's going to be a +2 at the end. And then I put some other good points, as many as I can, on the graph so I can count the rise and the run. And so when you're counting the rise and run, put as many whole number points as you can and go to the right. Then you'll see this one's going down 1, right 1, down 1, right 1. And so the slope would be -1 over 1, which simplifies to just -1. So they'll probably either put -1x, or they may even just get rid of that 1 and put -x. It would be the same thing. And then to decide which inequality you want to use, go to the edge of the shaded region and draw arrows pointing to the shaded region. Because these are pointing up, it's above. And so we know we want the greater than. And so we're going to put the greater than, but no line underneath it because it's dotted. Okay, and so for the second equation, or inequality, we're going to do the same thing. Starting with the y-intercept of -1. We know there's going to be a -1 at the end. Then I'm going to put some other good points on the graph. And then go to the right. So this one's going up 2, right 1. Up 2, right 1. And so the slope would be 2 over 1, which simplifies to just 2. And so for the inequality, go to the shaded region and draw arrows from these points to the shaded region. Each of these are pointing down, so we know it's below. And so we want to use our less than sign, once again with no line underneath it because it's dotted. Okay, so last one, they're both negative slopes, so don't lose that. So I'll start with this negative y-intercept. It's got a y-intercept of -1. And then if I put another good point, which is the intersection, and go to the right, it's going down 4. So -4, and then right 1. And if I go down 4 more,
Wait, how do you know if it's going down?
because I'm always going to the right. Okay, so from this point to this point, if I go from this point to this point, I have to go down to the right, down to the right. You don't ever want to go
So from
backwards.
that point, you have to go.
Yep. Always move to the right, just like you would read a book. Read left to right. And so then to the right would be +1. And so our slope is -4 over 1, which is just -4. And so -4x minus 1. And then this is a super steep line, so we have to go way up here to get to the shaded region. And the arrows would still be pointing up along this line to the shaded region. And so that's our above. And so we're going to grab the greater than sign. And this time it's a solid line, so we do want to draw a line underneath it. It's not dotted, so we need to take the time to draw the line. Okay, and so for the second line, his y-intercept is +2. And then if I put a bunch of other good points along this line, it's going down 1, right 1, down 1, right 1, down 1, right 1. So -1 over 1, which simplifies to -1. So -1x plus 2. And then all my arrows to the shaded region would be pointing up. And so we have a greater than or equal to because it's shaded above. So greater than or equal to.